Assalamualaikum and hello, my name is Salika. In this video, I would like to explain to you about the topic of leachate. Leachate is defined as any contaminated liquid that is generated from water percolating through a solid waste disposal site, accumulating contaminants and moving into subsurface areas. It varies widely in composition regarding the age of the landfill and the type of waste that it contains. It usually contains both dissolved and suspended material. In fact, the term leachate is so often applied to landfill leachate, both within the waste management industry and outside, that it's easy to forget that leachate is the term used for any liquid produced by the action of leaching. Leaching occurs when water percolates through any permeable material. Next is the components of leachate collection system. There are many components to a collection system, including pumps, manholes, discharge lines, and liquid level monitors. However, there are four main components which govern the overall efficiency of the system. These four elements are liners, filters, pumps, and sumps. Liners. Natural and synthetic liners may be utilized as both a collection device and as a means for isolating leachate within the field to protect the soil and groundwater below. The chief concern is the ability of a liner to maintain integrity and impermeability over the life of the landfill. Subsurface water monitoring, leachate collection, and clear liners are commonly included in the design and construction of a waste landfill. Leachate drainage system. The leachate drainage system is responsible for the collection and transport of the leachate collected inside the liner. The pipe dimensions, type, and layout must all be planned with the weight and pressure of waste and transport vehicles in mind. The pipes are located on the floor of the cell, above the network lies an enormous amount of weight and pressure. To support this, the pipes can either be flexible or rigid, but the joints to connect the pipes yield better results if the connections are flexible. Filters. The filter layer is used above the drainage layer in leachate collection. There are two types of filters typically used in engineering practice: granular and test. Sumps or leachate well. As liquid enters the landfill cell, it moves down the filter, passes through the pipe network, and rests in the sump. As collection systems are planned, the number, location, and size of the sumps are vital to an efficient operation. When designing sumps, the amount of leachate and liquid expected is the foremost concern. Areas in which rainfall is higher than average typically have larger sumps. A further criterion for sump planning is accounting for the pump capacity. The relationship of pump capacity and sump size is inverse. If the pump capacity is low, the volume of the sump should be larger than average. Method of leachate management. Re-injection into landfill. One method of leachate management that was more common in uncontained sites was leachate recirculation, in which leachate was collected and re-injected into the waste mass. This process greatly accelerated decomposition and therefore gas production, and had the impact of converting some leachate volume into landfill gas and reducing the overall volume of leachate for disposal. However, it also tended to increase substantially the concentration of contaminated materials, making it a more difficult waste to treat. Environmental impact. The risks from waste leachate are due to its high organic contaminants concentrations and high concentration of ammonia. Pathogenic microorganisms that might be present in it are often cited as the most important, but pathogenic organism counts reduce rapidly with the time in landfill, so this only applies to the freshest leachate. Toxic substances may, however, be present in variable concentrations, and their presence is related to the nature of the waste deposited. Most landfills containing organic material will produce methane, some of which dissolve in the leachate. This could, in theory, be released in poorly ventilated areas in the treatment plant. The greatest environmental risks occur in the discharge from older sites constructed before modern engineering standards become mandatory, and also from sites in the developing world where modern standards have not been applied. There are also substantial risks from illegal sites and ad hoc sites used by organizations outside the law to dispose of waste materials. Leachate streams running directly into the aquatic environment have both an acute and chronic impact on the environment, which may be very severe and can severely diminish biodiversity and greatly reduce population of sensitive species. Where toxic metals and organic are present, this can lead to the chronic toxin accumulation in both local and far distant populations. Reverse impact by leachate are often yellow in appearance and often support severe overgrowth of sewage fungus.